Here is a question that sounds simple. What is the number 2? Not 2 apples. Not 2 people. The number itself. The abstract thing that all pairs have in common. You can't see it, touch it, or weigh it, and yet mathematics insists it exists. That it has properties. That facts about it are either true or false. So what kind of thing is it? This is the philosophy of mathematics. And it's far stranger than it sounds. The oldest answer is Platonism. Mathematical objects exist independently of minds or matter. The number 2 isn't invented. It's discovered. It exists in some abstract realm. The way physical objects exist in space. When Euclid proved that there are infinitely many primes, he wasn't inventing new objects. He was revealing truths about things that already existed. This view has powerful defenders. The mathematician G.H. Hardy said he had never done anything useful, meaning no discovery he made was merely invented. Mathematical reality simply was, and he glimpsed it. Platonism has an immediate problem. If numbers exist in some abstract non-physical realm, how do we know anything about them? Knowledge usually requires causal contact. You know fire is hot because fire burns you. But the number 2 can't burn you, affect your neurons, or interact with anything physical. Philosopher Paul Benacerraf crystallized this as a dilemma. Any good theory of mathematical truth makes mathematical knowledge impossible. And any good theory of mathematical knowledge makes mathematical truth trivial. You can have truth or you can have access. Not both. One response. Deny that numbers exist at all. Nominalists say mathematical objects are fictions. Useful ones. But fictions nonetheless. When we say 2 plus 2 equals 4, we're not describing some abstract realm. We're following rules of a formal game. Or making claims that could in principle be paraphrased away without mentioning numbers. Hartree-Field tried to show that physics could be done without numbers at all, using only geometric relations between space-time points. It was a heroic effort. Most mathematicians found it deeply unconvincing. Gottlieb Frege had a different vision. Reduce arithmetic to logic. Numbers aren't mysterious abstract objects. They're logical structures. The number 2 is the concept of being a member of all two-membered sets. Define it precisely enough and arithmetic falls out of pure logic. No mysterious Platonic realm needed. Frege spent decades building this foundation in his Grundgesetz. It was, by any measure, one of the greatest philosophical projects ever attempted. Then, just as the second volume was going to press, he received a letter from Bertrand Russell. Russell had found a contradiction at the heart of Frege's system. Consider the set of all sets that do not contain themselves. Does it contain itself? If it does, it doesn't. If it doesn't, it does. This is Russell's paradox. And it destroyed Frege's logicist program. Frege's response, in a footnote to his second volume, is one of the saddest sentences in intellectual history. A scientist can hardly meet with anything more undesirable than to have the foundations crumble away just as the work is finished. David Hilbert proposed a way out. Formalism. Mathematics isn't about objects at all. It's a formal game played with symbols according to rules. The meaning of those symbols is irrelevant. All that matters is consistency. That the rules never lead to contradiction. If you could prove mathematics was consistent from within mathematics itself, you'd have secured all of math on safe logical ground. Hilbert called this program his greatest challenge. In 1930, he declared, "We must know. We will know." 1 year later, Kurt Gdel proved why we couldn't. Gdel showed that any consistent formal system rich enough to express arithmetic contains true statements that cannot be proved within that system. Not hard to prove, impossible in principle, and even more devastating. Such a system cannot prove its own consistency. Hilbert's program was dead. Mathematics could not be secured from within. Every formal system stands on assumptions it cannot justify. The truths of arithmetic stretch beyond any axioms we choose. If formalism was right that math is just symbol games, Gdel showed the games have no end and no safe foundation. A more recent answer is structuralism. Numbers don't exist as isolated objects. What matters is their position in a structure. The number 2 just is whatever plays the role of 2 in the natural number sequence. Coming after 1, before 3, being the sum of 1 and 1. There's no deeper question about what numbers really are. The Washington Monument and the Eiffel Tower are both second in some ordering. But second isn't a thing. It's a position. Structuralism captures the mathematician's intuition that what matters in mathematics is always relational, never intrinsic. Here's what makes this more than academic puzzle solving. Physicist Eugene Wigner called it the unreasonable effectiveness of mathematics. Abstract mathematics, developed with no application in mind, repeatedly turns out to describe physical reality with uncanny precision. Riemann developed his non-Euclidean geometry as pure speculation. 60 years later, Einstein needed exactly that geometry for general relativity. Complex numbers were invented to solve equations, and turned out to be the language quantum mechanics cannot function without. If numbers are just fictions or formal games, why do they describe the universe so well? That question has no agreed answer. And until it does, the number 2 remains one of the deepest mysteries in philosophy.